9.4 is over scalar products of two vectors, and we're just going to go over this first section together because there's some connections I want you to make down here to what the next video is you're going to watch. I've noted down here at the bottom what the video is I want you to watch. It's on the chapter 9 and 10 playlist, and it should be listed right after this video, so watch for that to be there. So a scalar product of two vectors. A scalar product, sometimes called a dot product. So if you hear this word or this word, know that they are interchangeable. These are the formulas that come out of 9.4 that would be on your HL formula sheet. So you should know that this is here, and then we won't go over this component of the formulas until 9.4 part 2, so after the next time I see you in class. But this is also available for you to use if you needed to. Okay. A dot product or a scalar product does not produce a vector. It produces a scalar, not a vector. Okay. Which means that we're looking at a horizontal answer. We're looking at something that is going to be a term that only has a horizontal component, not a vertical component like a vector does. So I want you to think back to things that we've done in the past. We've scaled numbers before. You may not be thinking of it that way, but we have scaled it. So if I said, what is 5 scaled by 3 or 3 scaled by 5, I could say that here are my two numbers, and they live on the number line. 1, 2, 3, 4, 5. Okay, and I'm going to take a measure of 5, and I'm going to scale it by a measure of 3. So I'm not putting this on here or anything like that. It's not like I'm adding this term and putting it on the end. What I'm doing is I'm saying that I have 5, and I'm going to take 3 of this quantity. So I'm going to take 1, 2, and then of course this doesn't look very nice, but there's 3 of that quantity, which would be down here at 15. So I could say that 5 scaled by 3 is 15. I could also have done 3 scaled by 5, and I would have got the same answer. I would have had 3, and I would have said, in that instance, that I have a quantity of 5 of this 3. So I'm going to take this guy and I'm going to stretch him to 5 times his original length, or I'm going to make 5 of them in that repeated addition type of model. So 1, 2, 3, 4, well, 5. We're going to pretend that all of those look the exact same length. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And both of them and at the same location, 15. So no surprises there. It wasn't like a mind-blowing moment, I would hope, at least. So we scaled a term by a term, and I took you could think of 3 as a vector. It's just a vector with no vertical component. And I took my vector of 5, which you can also think of as a horizontal vector, and I'm scaling them up. So when you're thinking about dot products, I want you to think about scalars. It's like a stretch in the horizontal direction. There's not going to be a vertical component on what the answer is.